All right, let's jump right into one of the most powerful ideas shaping the future of AI and data science today. It's called the ladder of causation. And you can think of it as our guide for moving beyond just seeing patterns in the world to actually understanding why things happen.
So let's start with a simple question. Does a rooster's crow cause the sunrise? I mean, it sounds kind of silly, right? Every single morning, without fail, the rooster crows and then the sun comes up. They are perfectly 100% correlated. But we all know, just intuitively, that one has nothing to do with the other. The real question is, how do we know that? This little puzzle actually gets to the very heart of a huge problem.
You've probably heard that first part a million times. Correlation is not causation. It's like the first rule of statistics. But look at the second part of that quote from computer scientist Judea Pearl. He points out that traditional statistics is amazing at finding correlations, but it literally gives us zero tools to figure out what causation even is. And that's the void that this new science of causality is here to fill.
So before we can even think about climbing this ladder, we need to get our gear in order. We need the right building blocks. See, you can't just stare at a spreadsheet of data and expect to find causes. You have to start with what's called a causal model. It's basically a blueprint of how you think the world actually works. And this blueprint is made up of a few key pieces.
Okay, first up, we've got the confounder. Now, think about a barometer. When the needle on a barometer drops, it's a pretty good sign it's about to rain. They're highly correlated. But does the barometer cause the rain? Of course not. There's a hidden player here, a common cause, atmospheric pressure. The pressure drops, which causes the barometer to fall and causes it to rain. That's the confounder, a shared cause that creates a phantom relationship between two other things. Next up is the mediator. This one's a lot more straightforward. It's just a causal chain of events. So a fire starts, which causes smoke, and the smoke is what triggers the fire alarm. The smoke here is the mediator. It's the how, the mechanism that connects the cause, the fire, to the effect, the alarm. Simple as that. Now, for the one that trips everyone up, the collider. A collider is something that is caused by two separate things. So let's look at this example, a startup's profitability. You could have a brilliant CEO, high expertise that leads to profit. Or you could just be lucky and have no competition, which also leads to profit. Now, here's the trap. What if you decide to only study successful, profitable companies? You've just walked right into something called collider bias. Because in that elite group, it's going to look like expertise and a lack of competition are somehow negatively related. You'll only find brilliant CEOs in tough markets and lucky ones in easy markets, creating the bizarre, totally fake correlation that doesn't exist in the real world. So you might be wondering, where do these causal models even come from? Well, it's not just guesswork. It's this really cool partnership between human knowledge and smart algorithms. You start with domain experts, doctors, economists, people who know their field inside and out, and they provide the initial assumptions. Then we let causal discovery algorithms loose on the data. Some of them work like detectives, using tests to rule out connections one by one. Others are more like architects, building up tons of possible blueprints and then scoring each one to see which best explains the reality we're seeing in the data. And all of that brings us to this. This is the big idea we've been building towards, the ladder of causation. It has 3 rungs, and each one represents a monumental leap in thinking. This isn't just a cute metaphor. It's a real mathematical framework for understanding what it means to reason about cause and effect. So let's start at the very bottom.
The first rung, the ground floor, is association. The core question at this level is super simple. What if I see? It's all about observing the world, spotting patterns, and noting what goes with what.
Now, this is the world where most animals live. And really importantly, it's where most of our current machine learning and AI systems live too. They're absolute masters at finding subtle correlations in massive amounts of data and then making predictions. Think of an owl learning that a certain rustle in the leaves is associated with a mouse. And that brings us right back to our rooster. Rung 1 is powerful. It can definitely tell us that the rooster's crow and the sunrise are linked. It can predict with incredible accuracy that if you hear the crow, the sun is about to come up. But it has absolutely no idea why. It can't tell you which one causes the other, or if neither does. It only knows that they're associated. Okay, time to climb. Welcome to Rung 2, Intervention. And notice the huge change in the question. We're moving from a passive, what if I see, to an active, what if I do? This is a game changer. And you can actually see the difference right here. On the left, that's rung 1. It's about looking at data of patients who, for whatever reason, chose to take a treatment. But look at the right side. That's rung 2. We're asking what would happen if we intervene, if we force everyone to take the treatment.
That little do in the equation is called the do operator, and it's everything. It symbolizes breaking the natural flow of things to conduct an experiment.
This is the level of scientists and engineers. It gives us the power to predict what will happen if we change something. It lets us answer real-world questions like, if I actually take an aspirin, will my headache go away? Or, if we change this policy, what will the effect be? To answer questions like that, you need more than just data. You need a causal model.
And finally, we make it to the very top of the ladder, rung 3, counterfactuals. And the question here is maybe the most human question of all. What if I had done things differently?
This goes beyond just doing experiments. This is the realm of imagination, of retrospection. It's about comparing the world as it actually is to a world that might have been, but wasn't. It requires us to spin up an alternate reality in our minds and reason about it.
These are the questions that let us ask why. Think about it. When you ask, my headache is gone, was it the aspirin? What you're really asking is, in a parallel world where everything else was the same, but I didn't take the aspirin, would my headache still be here? That's a counterfactual, and it's the basis for understanding things like regret, blame, and credit.
So here it is, the big showdown. On one side, you've got traditional data analysis, living on rung 1. It's brilliant at finding patterns and telling you what is. On the other side, you have causal modeling. This is what allows us to climb the ladder. It's not just about finding patterns in data, it's about building a model of the world itself, so we can ask what if, and ultimately answer why.
And this really is the whole point. The ladder of causation isn't just a cool theory. It's a blueprint for building truly intelligent AI. See, today's AI can predict a stock's price with terrifying accuracy, but it can't tell you why it went up. It can't tell you what would have happened if a different policy had been in place. This ability to reason about what might have been, that's the core of human intelligence. It's the missing piece that will elevate AI from just a pattern-matching machine to a true partner in discovery.
You know, we started with a simple question about a rooster. And the reason we know the crow doesn't cause the sunrise is because we can easily imagine a world where the rooster is silent and the sun rises anyway. That's a rung 3 answer. But just imagine the questions we could finally answer in medicine, in economics, in climate science, when our technology can finally climb to the top of this ladder and ask those same profound why questions about the biggest challenges we face.